Hello again, we continue 10.4 with 19. Same question, we are asked to find the area of the region enclosed by one loop of the curve. So sine 4 theta. Let's grab the calculator, go to y equals, and we have sine, and then 4 theta. 4 theta, and let's see the graph. Well, let's zoom in. Okay, very good. So what we need to determine again is the angle. So the graph looks something like this in each quadrant. So we are only asked to determine the area of one loop, they say. On 19 again. Find the area of the region enclosed by one loop of the curve. Okay, so we have to determine theta, which is A, and theta, which is B. So we can determine the area of 1/2 from A to B, of course, from r squared d theta. Okay, so again, how do we determine this? We notice that the curve passes through the origin, which means where r is 0, we have theta equals A and theta equals B. So when r is 0, we have sine 4 theta equals 0. Remember from trig, sine is 0 at this point and at this point. Two positive angles we need here. So then 4 theta will be 0 plus 2 pi k, or 4 theta equals pi plus 2 pi k. So this is a general solution. So from here, from the first possibility, 4 theta equals 0, then theta equals 0. And for 4 theta equals pi, we get theta equals pi over 4. So then we have from 0 to pi over 4. I will continue with a triangle, jump over all that. So we have 1/2, and sine changes into 1 minus cosine 8 theta over 2 d theta. So then we have 1/4 outside. The integral of 1 is theta from 0 to pi over 4. And then minus, this is sine 8 theta over 8 from 0 to pi over 4. And let's see what we get. So 1/4 outside. So then this will be pi over 4. There is no point in plugging in 0. And let's see what happens here. 8 times pi over 4 is 2 pi, but this will be 0. And when I plug in 0, again, this piece is 0. So this is pi over 16. Okay, so let's look at one example with area between or among curves. Let's say we have two. The recommended one was 23. So let's look at 23 on page 700. I don't want to make an error here and put them in the incorrect order, so this is page 6. Okay, so here we're asked to find the area of the region that lies inside the first curve and outside the second curve. Inside this one, outside this one. Okay, so let's take a look. Calculators. Y equals clear, and we have 4 sine. I could have just changed the argument, but that's okay. So we have 4 sine theta, and the other one is 2. So let's graph. So let's zoom out a little bit. So again, the blue curve is the first one, and the red curve is the second one. So here is the scenario. This is one curve, and this is the other. And they're asking us to determine the area inside the first curve, but outside the second one. So this is the area. So as you remember, first of all, we have to determine the points of intersection. So that's one thing. Secondly, what we need to determine, what we need to understand is that we will have the upper minus lower. So the area will be 1/2 the integral from, of course, this theta and this theta. Theta equals A and theta equals B. So from A to B, I'm not going to write it. But from the upper squared, of course. So this is 16 sine squared theta minus lower, of course, squared d theta. So now let's determine the thetas. So we set them equal to each other, of course, in this case. Sine theta equals 2, which means sine theta equals 1/2. And let's see what we get when we determine sine theta equals 1/2. We have theta from the unit circle. So we know that there are two angles, this angle and this angle, with the same sine 1/2. So this is pi over 6, and this is pi minus pi over 6, which is 5 pi over 6. So then we have pi over 6, and theta equals 5 pi over 6. That's all we needed. We put them in, pi over 6 and 5 pi over 6. Jump over all that and continue here. So let's see. 1/2 outside. Then we have 16. Sine squared has to be changed into 1 minus cosine 2 theta over 2, of course, from pi over 6 to 5 pi over 6, and minus 4 theta from pi over 6 to 5 pi over 6. Okay, so this is 1/2, and this is 8. The integral from 1 will be theta from pi over 6 to 5 pi over 6, and minus also 8 sine 2 theta over 2 from pi over 6 to 5 pi over 6. And this one I can already calculate. Minus 4, 5 pi over 6 minus pi over 6 is 4 pi over 6, which is 2 pi over 3. Okay, let's see what else is here. Now let's see what happens when we plug in these. No, they will not be 0. Nope. Okay, it doesn't appear. So let's see. So we have 8. Again, 5 pi over 6 minus pi over 6 is the same thing. It's 4 pi over 6, which is 2 pi over 3. And this is minus 4. Sine of 5 pi over 3 minus sine 2 pi over 3. So let's determine those. I'm going to put it here. So 2 times 5 pi over 3 is 5 pi over 6 is 5 pi over 3. What is 5 pi over 3? It's 300 degrees, right? So making sure 2, so yes, we have 5 pi over 3, and 5 times 60, 300. So the angle is in the 4th quadrant, and sine will be negative, and it will be negative the square root of 3 over 2. And then minus. When I plug in, again, pi over 3, because it's 2 times pi over 6, which is pi over 3. So that is also the square root of 3 over 2. Okay. And then minus 8 pi over 3. And I have to erase this because it's confusing here. Sorry about that. What will I do without my whiteout? It'll be a tragedy here. Sorry for the wait. 1 second. 1 second. Okay. Good. So now let's calculate all this, whatever it is. So on page 7 equals. So 1/2. So this is 16 pi over 3. These are all plus. So 2 the square root of 3 divided by 2 will be the square root of 3. So this plus 4 the square root of 3. And minus 8 pi over 3. So 8 pi over 3 plus 4 the square root of 3. So when I distribute 1/2, I get 4 pi over 3 plus 2 the square root of 3. And we determine the area enclosed. I think we had enough of these examples, and let's move on to the arc length. Arc length. Similar formula as we had before. So we know that r is basically a function of theta. And theta, of course, goes from a to b. So then the arc length will be the integral, of course, from a to b. From the square root, we had a similar formula all this chapter. R squared plus dr over d theta squared d theta. Okay, so let's look at an example here, like 49 on page 701. And find the exact length of the polar curve. So r equals 2 cosine theta, and theta is given to us between 0 and pi. Remember, we have to, as you see the formula, we have to define dr over d theta, which is -2 sine theta. So then the arc length will be the integral from 0 to pi from the square root. I square this and I get 4 cosine square theta, and then plus I square this and I get 4 sine square theta d theta. But I know that when I factor out the 4 and take it out of the square root, I have 2, the integral from 0 to pi. And what is left here is sine squared plus cosine squared, which is 1, and the square root of 1 is 1. So then I have 2 theta from 0 to pi, and I only plug in pi. So the arc length is 2 pi. Okay, finally, let's talk about tangents. And if you remember, we had the formula dy over dx equals dy over dt over dx over dt. This is y. Also, to refresh your memory, we had that y equals r sine theta and x is r cosine theta. We knew this from the very beginning of the polar coordinates. So this is a function f of theta and times cosine theta, and this is a function f of theta times sine theta. Okay, so we need to continue the formula using the given setting. So here's dy over dt, but of course this time we're differentiating with respect to theta, because we don't have t, we have theta in the problem. Okay, so dy over d theta is dr over d theta times, because it's a product, times sine theta plus r and sine theta prime, which is cosine theta, and everything over. Now I differentiate x with respect to theta. So again, the same thing, dr over d theta times cosine theta, but this time minus r, because when I differentiate cosine, I get sine theta. So I'm going to write the formula one more time because of that page number there, it may be confusing. So then we are looking at dy over dx, which is dr over d theta times sine theta plus r cosine theta over dr over d theta times cosine theta, but minus r sine theta. And based on this, we can determine tangents, slopes, vertical tangents, horizontal tangents. So let's start with 63. 63 on page 702. We have r equals 2 cosine theta, and theta equals pi over 3. And we're told find the slope, just the slope, of the tangent line to the given point, to the given polar curve at the point specified by the value of theta. Okay, so basically all we have to determine is this and plug in pi over 3 for the given r equals 2 cosine theta for the given polar curve. All we have to do is determine this expression of dy over dx and plug in pi over 3, and that will be the slope of the tangent line to the graph of this when theta equals pi over 3. Good. So then dy over dx will be dr over d theta. When we differentiate r with respect to theta, we get -2 sine theta plus r cosine theta. I have to plug in r. So 2 cosine squared theta over dr over d theta again. So this is -2 sine theta multiplied by cosine theta, and then minus, I have to plug in r, which is 2 sine theta cosine theta. Very easy. All I have to do at this point is just plug it in. Plug in theta equals pi over 3. So let's see what we get. So -2 sine pi over 3 is the square root of 3 over 2 plus 2. Cosine pi over 3 is 1/2, so I square that. -2 sine pi over 3 again is the square root of 3 over 2. Cosine is 1/2 minus 2 sine. I should have just said -4, same thing. So sine again is the square root of 3 over 2 and times 1/2. Okay, so let's see what we get. I will only simplify these two. Okay, I'm on page 9. Okay, let's see. So -2 to the square root of 2 plus 1 over 2. Everything divided by. So this is the same thing. I'm going to multiply it by 2. So minus the square root of 3. So -2 the square root of 3 plus 1 over -2 the square root of 3. So I'm getting 2 and 2. And let me see, do I have a typo in here? -2. Oh, yes, yes, yes. Yes, yes, yes. So dr over d theta. So dr over d theta is cosine prime times sine. Careful, I forgot to multiply by sine. So I get sine squared, everything else okay. So that's why my numbers are, so this will be squared. Aha. Okay, I'm just going to easy peasy. Just going to remove that and continue here. Okay, so we have -2 times 3 over 4 plus 2 times 1 over 4. Okay. And the denominator is basically -4 times the square root of 3 over 2 times 1/2. Okay. So these go away. I still have -3/2 plus 1/2 is negative 2 over 2, which is negative 1. And the denominator is negative the square root of 3. When I rationalize, I get the square root of 3 over 3. And that is it. Okay. Good. So let's also look at one more. Find the points on the given curve where the tangent line is horizontal and vertical. Important type of problem. 71 on 702. We are given r equals 1 plus cosine theta. Find the points where, so we are looking at horizontal tangents and vertical tangents. Okay, so that's the last thing we need to do here. Okay, I'm not gonna throw this away, I'm gonna put it underneath. Okay, so of course, like before, we have to find dy over dx. And if you, we can go back and copy the formula. But what I wanted to say is that a horizontal tangent requires this to be 0 when this is not 0. A vertical tangent requires this to be 0 when this is not 0. So careful on that. So again, we have dr over d theta times sine theta plus r cosine theta over dr over d theta times cosine theta and minus r sine theta. So first, that's the first step. We have to determine dy over dx, and after that, we will work our way on step by step for tangent and horizontal and vertical tangents. Okay. I will stop here and continue in the third video because we exceeded 20 minutes. Thank you.